At the edge of a municipal zoning office, a wall-sized map displays blocks of streets, parcels, and public facilities in carefully coded colors. Among the layers of information, stormwater lines, fire hydrant radii, transit, corridors, parking layouts appear as repeating rectangles arranged with precise spacing. These shapes are not design suggestions or aesthetic choices. They represent regulated dimensions that determine how much land can be developed, how traffic flows through private lots, and whether emergency vehicles can operate safely. In this administrative setting, parking spaces become visible, not as painted lines on asphalt, but as standardized units embedded in legal frameworks and urban calculations. City planning departments rely on dimensional standards to evaluate building proposals. When a developer submits plans for a supermarket or apartment complex, the number and size of parking spaces must comply with municipal codes. A standard stall width, often around 2.4 to 2.7 meters in length, commonly 4.8 to 5.5 meters, allows planners to verify capacity without recalculating each design from scratch. The dimensions function as shared assumptions between architects, traffic engineers, and regulators. Without these shared measurements, each project would require individualized negotiation, delaying approvals and complicating enforcement. The need for such standards emerged alongside the expansion of automobile ownership in the mid-20th century. As cars became wider and longer, early, informal parking arrangements, curbside gaps, unmarked lots proved inconsistent and often unsafe. Municipalities faced complaints about blocked access, collisions in cramped lots, and fire lanes obstructed by poorly parked vehicles. Rather than regulating individual behavior alone, cities began codifying spatial requirements. By defining the minimum area required to store a vehicle, they shifted the problem from ad hoc enforcement to predictable design. Standardization also enabled coordination across jurisdictions. Automobile manufacturers produced vehicles for national markets, and road design manuals began recommending lane widths, turning radii, and parking dimensions that could accommodate the majority of cars. When cities adopted similar standards, drivers could expect that a parking stall in one region would accommodate the same vehicle in another. This consistency reduced uncertainty for travelers and commercial fleets, whose operations depended on predictable infrastructure. Within the institutional context of building codes, parking dimensions served multiple regulatory purposes simultaneously. Fire safety regulations require clear access routes for emergency vehicles, which in turn depend on predictable parking layouts that prevent encroachment into drive aisles. Accessibility laws mandate designated spaces with additional width for wheelchair access, integrating social policy into spatial standards. Stormwater management guidelines may influence the spacing and orientation of parking rows. To accommodate drainage infrastructure, each of these requirements interacts with the basic unit of the parking stall, reinforcing the need for stable, widely recognized dimensions. Procedures for measuring and marking parking spaces further stabilize their function. Surveyors establish lot boundaries and reference points before construction begins. Contractors then stripe spaces according to approved plans, using standardized measurements to ensure compliance. Inspections verify that the dimensions match code requirements before a property can open for public use. Through these repeated procedures, plan review, construction, inspection, and enforcement, the abstract dimensions in municipal codes become physically embedded in the built environment. Over time, the repetition of these practices has normalized expectations. Among drivers and property owners, a driver entering an unfamiliar parking lot does not need to evaluate whether a space will fit their vehicle. The standardized dimensions provide implicit assurance. Property managers can estimate capacity, turnover rates, and revenue projections based on known spatial units. Insurance assessments and liability considerations also rely on standardized layouts, which help define what constitutes reasonable accommodation for vehicles and safe circulation patterns. The stability of parking dimensions does not imply uniformity without adaptation. Municipal codes often specify ranges rather than single measurements, allowing adjustments for angled parking, compact car spaces, or constrained urban sites. However, these variations remain anchored to a common baseline that preserves interoperability. Even when a city introduces smaller spaces to encourage efficient land use, the decision is framed in relation to established standards, ensuring that deviations remain legible to designers and regulators. Institutional coordination extends beyond city planning offices. Professional organizations such as transportation engineering associations publish design manuals that recommend parking dimensions based on vehicle data and safety research. These guidelines inform local codes, creating a feedback loop between empirical studies and regulatory practice. When vehicle sizes change or accessibility requirements evolve, updates to these manuals gradually influence municipal standards, allowing the system to adapt without losing coherence. The economic implications of standardized parking dimensions are significant. Land valuation, development feasibility studies, and zoning negotiations all depend on predictable parking ratios and spatial requirements. A developer calculating the viability of a mixed-use project must account for the number of parking spaces required by code and the area each space occupies. Because these dimensions are standardized, financial models can be constructed with confidence, facilitating investment and long-term planning. In this way, the parking stall becomes a unit of economic calculation. As well as a physical space, standardization also simplifies enforcement. Municipal inspectors can assess compliance by measuring a sample of spaces, rather than evaluating each vehicle's fit. Violations such as undersized spaces or obstructed access aisles can be identified, objectively reducing disputes between property owners and regulators. The clarity of dimensional standards supports consistent enforcement, which in turn reinforces public trust in regulatory processes. The persistence of these standards is evident in the way they accommodate technological and policy shifts. The introduction of electric vehicle charging stations, for example, often occurs within existing parking layouts, with modifications to equipment rather than stall dimensions. Similarly, policies encouraging shared parking or reduced minimums still rely on standardized measurements to calculate capacity and compliance. Even as cities experiment with reducing car dependency, the established dimensions continue to function as a baseline for transitional planning. In dense urban areas where land constraints challenge conventional layouts, the presence of standardized dimensions enables deliberate departures rather than arbitrary improvisation. Designers can propose mechanical parking systems, tandem spaces, or reduced stall sizes, but these alternatives are evaluated against the established norms. The standards provide a reference point that allows innovation to be assessed in terms of safety, accessibility, and operational efficiency. The continued function of standardized parking dimensions today rests on their integration into multiple layers of governance and practice. They are embedded in zoning codes, reinforced by professional guidelines, implemented through construction procedures, and normalized through everyday use. Their stability does not derive from a single authority, but from the convergence of legal requirements, technical standards, economic calculations, and user expectations. As cities evolve, debates about land use, transportation policy, and environmental impact increasingly question the quantity of parking required. Yet even when minimum parking requirements are reduced or eliminated, the dimensions of individual spaces remain standardized. This persistence reflects their role as a foundational unit in the management of urban space, by providing a common measure that aligns design, regulation, and daily practice. Standardized parking dimensions continue to support coordination across institutions and maintain functional order in the built environment.